Hi, so this is taking Rook polynomials to the next level, part 2. I was helping an engineering math students with her discrete maths, and she so happened to be having Rook polynomials. And as I started helping her, I found it to be an interesting topic and she also enjoyed it. So it has a lot of applications in computer science. So we had the first class on Rook polynomials. The second class, which I'm going to be doing today, is just a continuation of that. So I'll just discuss a few basic points. So two pawns placed on a board having two or more squares are said to capture each other if they are in the same row or same column. And Rk denotes the number of ways in which k pawns can be placed so that no two pawns capture each other. And the polynomial 1 plus nx plus r2x squared plus rnx raised to n is called a Rook polynomial. So basically we need these things from the last class, and now coming to all this we had covered in the last class. Okay, so now today we'll be doing the expansion formula for Rook polynomials. In a given board C, suppose we choose a particular square and mark it as a star. And let D be the board obtained from C by deleting the row and column and containing the squared star, and E is the board obtained from C by deleting only the squared star. Then the Rook polynomial RCX is given by x r dx plus rex. And this is called the expansion formula for RCX, which we are going to do today. We are going to be solving problems using the expansion formula. So find the Rook polynomial for the 2 by 2 board using this expansion formula. Keep in mind that we can mark any cell as star. So if I mark 1 as star, D has only one square, that is 4. Because what is D? You delete that row and column. So here n is just 1 and RCX is 1 plus x. What happens to E? You're only deleting 4. So number of ways in which two pawns can be placed so that no two capture each other is just 2, 3. And n is 3. There are 3 squares. So rex is 1 plus 3x plus x squared. And by the expansion formula, which states that RCX is x r dx plus rex, we already saw r dx is 1 plus x and rex is 1 plus 3x plus x squared. Simplifying, you get RCX is 1 plus 4x plus 2x squared. Find the Rook polynomial for this 3 by 3 board using this expansion formula. Again, I mark the center square as star, so this is your D and this is your E with the star missing. So for the board D, n equal to 4 and R2 equal to 2, number of ways in which two pawns can be placed so that no two of them capture each other is 2. You can have one here and one here. And R3 and R4 is 0. N is 4, so r dx is 1 plus nx, that is 4x plus 2x squared. For E, n equal to 8. So number of non-capturing rooks for E will be, you have 1, 5. I will just zoom in so you can understand better. Yes, you have 1, 5, then you have 1, 7, 1, 8, 2, 4, 2, 6, 2, 5, 2, 8, 3, 4, 3, 7, 4, 7, 4, 8, 5, 6 and 5, 7. There are 14. So R2 equal to 4. And positions of 3 non-capturing rooks will be, you will have 1, 5, 7, 2, 4, 8, 2, 4, 6 and 3, 4, 7. So R4 equal to R3 equal to 4. And R4, R5, R6, R7, R8 is 0 because you cannot have 4 non-capturing rooks for a 3 by 3 board. So Rex will be 1 plus 8x plus 14x squared plus 4x cubed. 1 plus nx plus r2x squared plus r3x cubed. Again RCX is x r dx plus rex. So when you simplify, substitute for r dx and rex, you get 1 plus 9x plus 18x squared plus 6x cubed. Coming to the next question, by using the expansion formula, obtain the Rook polynomial for this board. Here, this is your board, so I'm going to mark 1 as star. So this is your D and this is your E. So for the board D, R1 is 5 and two non-capturing rooks can occupy 2, 4, 2, 7, 4, 8, 5, 7. So R2 is 4. So R dx is 1 plus 5x plus 4x squared. And for E, there are 7. So R1 is 7. And two non-capturing rooks can occupy. You can have 2, 4, 2, 6, 2, 7. Then 3, 4, 3, 5, 3, 7, 3, 8. Then 4, 8. Then you can have 5, 7. 6, 8 and 6, 7. So R2 is 11. And three non-capturing rooks can occupy the ways that you can have 3, 4, 8. Then you can have 2, you can have 3, 5, 7, 3, 5, 7 and 2, 6, 7. That's also possible. So R3 is 3. So Rex will be 1 plus 7x plus 11x squared plus 3x cubed, 1 plus nx plus R2x squared plus R3x cubed. And again when you substitute in RCX is xr dx plus Rex and substitute these values, you will get 1 plus 8x plus 16x squared plus 7x cubed. This is the expansion formula here. Now coming to the next question, by using the expansion formula, find the Rook polynomial for this board C. So I'm marking this 4 as star. We generally try to use the center square as star, but again there's no hard and fast rule. So D is just 1 and 2 and this will be E, 1, 3, 2, 5 and 6. For D, R1 is 2, R2 is 0, so R dx is 1 plus 2x. For E, what is R1? 5, there are 5 squares. So two non-capturing rooks can occupy the positions 1, 5, 1, 6, 2, 3, 2, 6, 5, 6, 3, 6. So R2 is 6. And three non-capturing rooks can occupy 1, 5, 6 and 2, 3, 6. So R3 is 2 and everything else higher than that is 0. So Rex is 1 plus 5x plus 6x squared plus 2x cubed. 1 plus nx plus R2x squared plus R3x cubed. So again using the expansion formula RCX is xr dx plus Rex, you get, substituting this, you get 1 plus 6x plus 8x squared plus 2x cubed. So that comes to the conclusion of the second level of Rook polynomials. So stay tuned in for the next class. Thank you and do subscribe.